Hi everyone, welcome back to Emmy's Calc class. Today we are learning the Taylor series. Here is the formula for the Taylor series, and we will break down some important parts, such as f to the power of n times a. This part represents the nth derivative of the series. So, for example, we can take the first derivative, second derivative, or the third derivative, and etc. to represent this nth derivative. Next, let's take a look at this denominator, which is n factorial. For example, the denominator can be 1 factorial, which is just 1, 2 factorial, which is 1 times 2, which is equal to 2, or 3 factorial, which is 1 times 2 times 3, which is equal to 6. Lastly, the a in this formula represents the center of the series. So this is the Taylor series. It is an infinite sum of polynomials, and that is what it looks like in its expanded form. These both equal the same thing. Again, infinite number of terms, and that is what it looks like written out. And here are some things you should know before we get into some examples. These are some derivative rules and integration rules that you may have learned from Calculus 1. Feel free to take a screenshot or pause here. Here are some other things you should know. These are patterns you should look out for when identifying Taylor series or sequences within the Taylor series. You should look out for if the series has alternating signs. So if it starts with a positive sign or a negative sign, notate that accordingly. If the series has odd or even numbers, also either use 2n or 2n plus 1. And lastly, look out for multiples. So for example, multiples of 3, you indicate it with 3n, or multiples of 4, you indicate it with 4n, and so on. So let's get started with this example. We are going to find the Taylor series for f of x is equal to sine of x centered at a is equal to 0. When the center is 0, this is also known as the Maclaurin series. So first we are going to find the first 4 derivatives of sine of x. So f of 0 is just going to be sine of 0. Now we take the derivative of sine of 0, which is going to be cosine 0. To find the second derivative, now we are going to find the derivative of cosine 0, which is negative sine 0. Next, for the third derivative, we take the derivative of negative sine 0, which is negative cosine 0. Lastly, for the fourth derivative, we take the derivative of negative cosine 0, which is just sine of 0. Now that we have found the first 4 derivatives, we are going to evaluate each derivative. So let's start. Sine of 0 is equal to 0. Cosine of 0 is equal to 1. Negative sine of 0 is still just 0. Negative cosine 0 is going to be negative 1. And lastly, sine of 0 is 0. And now that we have evaluated our derivatives, we can look at this pattern. So the first thing I am noticing is that there are odd numbers. And the second pattern I see here is that there are alternating signs. We can see that the first sign is a positive sign. Now we can look back at our pattern rules and see that odd numbers we will use 2 n plus 1, and alternating signs starting with positive is -1 to the nth power. Now our next step is going to be trying to capture this into our Taylor series formula. So let's write this with f of x is equal to sine of x. Now the first pattern we notice is that there are odd numbers in our series. From here, we will replace our n values with 2n plus 1. We write 0 for our a, since that is our center, and this is going to be all above 2n plus 1 factorial. Now we write x minus 0 to the 2nth power plus 1. And anything times 0 is equal to 0, so this cancels out. And now we can put this part, which is our distance from the center, on top of our n factorial. So it'll be x to the 2n plus 1 over 2n plus 1 factorial. And now we are almost there. We are just missing one more part that we need to capture, and it is the alternating signs, starting with the positive sign. So we are simply going to write our -1 to the nth power, and then the rest of the series. And that is our final answer. To save time, I went ahead and wrote out the expanded form of this Taylor series. Let's do one more quick example. We are going to find the Taylor series for f of x is equal to e to the power of x, centered at a is equal to 2. Let's start off with our original Taylor series formula. From here, we can replace our a's with 2, since we were given that 2 is the center. Now we will find the derivatives for e to the x at a is equal to 2. But we can recall from the derivative rule for exponentials that the derivative of e to the x is just e to the x. So with that in mind, the first 4 derivatives of e to the x is all just going to be e to the x. So from here, we can actually rewrite f of n times 2 is equal to e to the power of 2. So our final answer is going to be the summation of n at 0 to infinity e to the second power over n factorial times x minus 2 to the nth power. Yay! We did it! Thank you guys for watching. Please leave a like if this helped, and have a good day.